Bismillahirrahmanirrahim, dear students. Assalamu alaikum. Today we are going to start class 9, subject physics. Topic of today's lectures are examples 4.5, 4.6. Topic of today's lecture are examples 4.5, 4.6. Today we will discuss MCQs regarding chapter number 4, problem 4.1, 4.2, and 4.3 we will cover. Pages that will cover today 98. The example number 4.5 is on page number 98. Example 4.6 will be on page number 99. And example, and then the MCQ will be on 104 page, and problems will be on these three problems will be on 105 page. So these pages we will cover today. So first of all, I will start my lecture on with the, for example, 4.5, which is on page number 98. So if I read the example for you, page number 98, if you open the 9th class textbook, this example you can find on example 4.5 on page number 98. I read the statement of the numerical. A block of weight 10 Newton is hanging through a cord as shown in figure 4.25. Sorry, this is 4.2. 4.9, find the tension in the cord. So this is the block. This is the block whose weight is 10 Newton, and since this is tied up with the rope, this box is tied up with the rope, which is acting tension, which is acting upward direction, and it is supported with some support. So weight of the block is acting downward. You know the weight is always act downward. So weight is actually velocity with the relative W, and tension of the rope, which is acting upward, which is hanging, through which the box is hanging, it is acting upward. So tension is in upward direction, and while the weight is in downward direction. Weight always acts downward direction, as we have already discussed in our lectures. A block of weight 10 Newton, the weight of the block, this is the block, weight of the block is 10 Newton, is hanging through, it is hanging because it is hanging through cord, this is the cord. Find the tension in the cord, we need to find out tension, P in the cord. So what I'm going to do, this is the continuation of example 4.5. So if you open your book page number 98, you will find this example 4.5. So in this numerical, we are going to what we are given weight of the block, which is W is equal to 10 Newton, which is given to me. To find tension, tension is denoted with the capital T. So if I show you this block again, this is the block which is acting downward. So in the next slide, we are given the weight is 10 Newton given to me. In this numerical, we need to find a tension. Tension is denoted with a T. If we look at this there is no force acting on the x-axis direction. X-axis direction, so summation Fx will be equal to 0. Why summation Fx will be equal to 0? So, because there is no force acting along x-axis. So only the force which is acting on the box, which is lifting this box upward, is the vertical force. So we have vertical force over here, but there is no horizontal force acting on the force. So our horizontal force or x-axis forces will be 0. So you know the condition of equilibrium, summation Fx equal to 0. So there is no force acting along x-axis, but there is a force but there is a force acting on y-axis. What are the forces? Forces are tension, tension T, T and W. They are acting x-axis or have the same line of action. These forces have the same line of action because they are acting in the same line. So P is acting upward, while the wave is acting downward. So there are only the vertical forces acting on this body. So, so in this case, we have a summation effect equal to zero. So if I consider if I put this one T tension T, what are the vertical forces acting on this body? Tension which is acting upward, tension which is acting upward direction, tension which is acting upward direction, and the weight is acting downward direction. This is the convention. You can take the convention, use the convention as well. Whenever the force tension is acting, I'm taking the tension, all the forces which are acting in upward direction. I'm considering tension per positive sign with them. But all the forces which are acting downward direction, I am taking the convention minus sign. So tension is acting upward direction. So it is the only the vertical force which is acting upward direction. So I am considering this positive sign. But since the weight is acting downward direction, so I will take the negative sign with this equals to zero. So I am putting summation of Fy is equal to T minus W. T is the vertical force, W is also the vertical force, but they are in the same line of action. So minus W is shifted on the other side, so T will be W. Since we know, since we are given W is equal to 10 Newton, so our tension will be 10 Newton. So our result will be tension T equals to 10 Newton. So this is the end of the example 4.5. Now we consider the next example, which is 4.6 example on page number 99. If you open page number 99 of example 4.6, I read the statement of the convention first for you. A uniform rod of length 1.5 meter is placed over a wedge at 0.5 meters from its one end. A force of 100 newtons is applied at one of its ends near the wedge to keep it horizontal. Find the weight of the rod and the reaction of the wedge. So, students, I'm going to tell you what is wedge, what is the force we are applied, and what is the moment arm. These all things I will discuss now. So uniform rod, this is a uniform rod. This length is from here A point to B point. This is the uniform rod. A to B is the uniform rod of length 1.5 meters. 0.75 plus 0.5, it's gonna be 1.5. From A to B, if you add 0.75 plus 0.5, you will get 1 meter, 1.5 meters. 0.75 is placed over a wedge at 0.5 meters away from its one end. So from here, A to O distance is 0.5 meter, and from B to G distance is 0.75 meter. How can we find the distance O to G? 0.75 minus 0.5. So this triangle is the wedge. This is the wedge, and my rod is placing on the wedge. It's lying horizontally on the wedge. I name this point as A, and this point as B, and then this point, where the wedge is standing, where the wedge is, I name this point is O. So this is my another point, which is G, which is acting downward. These two forces are acting downward, and this is the only force which is called the normal reaction, is called is acting upward direction. So there are the two forces which are acting downward, and one at A and one at B, which are acting downward. Force F is acting downward. The G is acting downward. There is the only force which is called the normal action, which is acting upward direction. So Distance are given to me. B to G distance is 0.75. B to G distance is 0.75, and then 0.25 from OG, and AO is 0.5. So a uniform, I read the example again. A uniform rod, this is a uniform rod, this A to B is the uniform rod, is placed over a wedge, this is a wedge, is placed over a wedge at 0.5 meter from its one end. 0.5, this distance from from this point to this point, the distance is 0.5 meter. This point to this point is a 0.5 meter. So the example is a road balanced over the wedge. This is the wedge. So this is our wedge. So now I consider the example. We solve the example now. So given data, force is given to me, which is capital F. Please students don't write anything on the screen. Please don't write anything on the screen. Please. Okay. We are on this example. Now I'm moving towards example. I'm going to solve this example 4.6. Force is given to me 100 Newton. If you read the numerical, the force is 100 Newton, which is given to me. Then OA is 0.5 meter. Here O to A distance is 0.5 meter. Then OAG equals to BG. This distance A to G is equal to B to G. This is given to me. AG equals to BG 0.75. How can we find OG? OG distance we can find 0.75 minus 0.5. So you can find OG distance, which is 0.75 minus 0.5 is 0.25 meter. In this numerical, we are asked to find weight W and normal reaction R. Normal reaction weight W. What is the weight W? Weight W. We need to find out this weight because this force is given to be 100 Newton. But in this example we need to find out W and normal reaction. These two things are required to find out. Now, normal reaction, the weight is denoted with the letter W, and normal reaction is denoted with the capital R. Applying what I'm doing, I'm applying the second condition of equilibrium, taking torque about O. I'm going to apply the second condition of equilibrium, and the second condition of equilibrium is in which summation tau on the torque acting on the body is equal to 0. Since I'm using if we go to, if I go back to this slide, so I am taking the torque about O. So this force can move the body in anti-clockwise direction, and this force can move the body in anti-clockwise direction. This is the only force which is moving the body clockwise direction. So sum of all the forces acting on the body, which can move the body clockwise direction, equals to the sum of the torque moving the body anti-clockwise direction equals to. So first of all, I will take the sign convention because this force will move the body in anti-clockwise direction, and this force is moving the body in anti-clockwise direction. At the last 10 minutes, I will give you. question of answer of these questions, please don't write anything on the screen. It's very easy for me. So if I go back to your okay, so this is my figure. So I'm going to solve the numerical. So I'm taking the top. These are the two forces which are rotating the body in clockwise direction. F and W are the forces which are. If I take the convention plus sign over here, plus sign over here, and W cross OG minus minus W instrument plus instrument RH negative. R cross O. So if students, I'm going to take the convention. These are the two forces. Force W is acting downward. Source W is G at W is acting downward. These two forces are acting downward. This is the only force which is acting upward. So my convention will be I'm taking the normal reaction. I'm taking the normal reaction uh, as negative, and rest of the two forces, because these two forces F and W will rotate the body in anti-clockwise direction, and this normal direction will rotate the body clockwise direction. So my negative sign will be with the normal direction because it is moving the body in clockwise direction. But force F and W are taking as positive because they are moving the body in anti-clockwise direction. So sum of the dots will be equal to 0. Now, so now if I put the values over here, so here will be positive sign. So if I put the values in the formula, force is given to be 100 multiplied by then OA distance is 0.5. Look, force is 100 Newton and the distance is 0.4. Because I want to find the cost, that's why force is 100 multiplied by 0.5. So in this case, so if I take this W over there, the negative sign minus W times 0.25. So if I separate this out, so W value will be if you solve this, and W value will be 200 Newton. Next, if I applying first condition of equilibrium, so because there is no force acting on the body on the wedge x-axis, so x summation fx is equal to 0. But only the forces which are acting on the body, that either this can rotate the body in clockwise direction or in anti-clockwise direction, or there are the forces which are acting in vertical direction. So there are two forces are acting downward, and the one force is acting upward. So in this case, if I consider the downward force as negative and upward force as positive, so normal reaction is acting upward direction. So normal force, normal reaction is acting in upward direction, and the force is force and the weight is acting downward direction. So I'm taking the negative sign. So if I move this, for putting the value of 100, force as 100, weight is force as 100, and weight is 200. So you shift this one on the other side, so you will get normal reaction 300. 200 plus 100 is equal to 300 Newton. So our weight is 200 Newton and our normal reaction is 300. These are the two things which are required in this numerical. The weight of the weight of the balloon, which is 200 Newton, and normal reaction of the wedges R, which is acting upward, is 300 Newton. So this is the end of the numerical example 4.6. Now we move towards MCQs on page number 104. MCQs are on page number 104. If you open your 9th class textbook, the MCQs are on 104 page. I read the MCQs for you, and you mark it down. The first, encircle the correct answer from the given choices. First, MCQs is two equal but unlike parallel forces. Two equal and unlike parallel forces having different line of action produced. First choice is a torque. Second is a couple. C is equilibrium, and D is neutral equilibrium. So my second choice, D, one, a couple, is the right one. So student, you mark couple, D choice as the right one. The second MCQ is the number of forces that can be added by head to tail rule are. So first choice is 2, A choice is 2, B choice is 3, C choice is 4, and D choice is any number. So my right answer is any number. So you mark D as the right one. The MCQ number 3 is the number of perpendicular component of a force are. A choice is 1, B choice is 2, C choice is 3, and D choice is 4. So in our scenario where we have already studied perpendicular component. So there are two perpendicular components, so the B choice is the right one. MCQ number 4, a force of 10 Newton is making an angle of 30 degree with the horizontal. Its horizontal component will be, if you use the formula, since we need to find out fx, so formula is fx is equal to f times cos theta. If you use this formula and force is 10 Newton and theta is 30 degree, you will get the answer D choice, which is 8.7 Newton. The 8.7 Newton G choice is the right one. Fifth MCQ is a couple is formed. A couple is formed. Two forces perpendicular to each other. Two like forces, parallel forces. C. Two equal and opposite forces in the same line. And D. Two equal and opposite forces not in the same line. So my D choice is the right one. Two equal and opposite forces not in the same line. MCQ number 6 is a body is in equilibrium when its A choice is acceleration is uniform, B choice is speed is uniform, C choice is speed and acceleration are uniform, and D choice is acceleration is zero. So my MCQ number 6, the choice D1 is the right one. which is acceleration is zero. 7 MCQ is a body is in neutral equilibrium when its center of gravity is at its highest position. A choice. B choice is at the lowest position. C choice is keeps its height if displaced, and D choice is situated at its bottom. So my C choice keeps its height if displaced, because when we discuss the neutral equilibrium topic, we have studied whenever the body is rolled down, it keeps the other, it moves to other position, but its height remains same. So my choice C is the right one, which is keeps its height if displaced. The last MCQs of chapter number 4, which is eighth one, racing cars are made stable by A choice is increasing their speed, B is decreasing their speed, C is lowering their center of gravity, and D is decreasing their width. So my C choice is right one, lowering their center of gravity. Thank you. The MCQs we have so far done. Now we are moving towards problems of, which are on page number 105. If you 105, page number 105, example, problem number problem number 4.1. I read the statement of the MCQ as find the resultant of the following forces. First we need to do 10 Newton along x-axis, 6 Newton along y-axis, and 4 Newton along negative x-axis. So step 1, we need to choose a suitable scale for this in order to solve this question. Take 1 Newton, I suppose 1 Newton is equal to 1 Newton is equal to 1 centimeter. Then 10 Newton will be 10 centimeter. This will act on long x-axis. So 6 Newton is 6 centimeter, because 1 Newton is 1 centimeter, then 6 Newton is 6 centimeter, and similarly 4 Newton will be of 4 centimeter. So I choose the scale, let 1 Newton is equal to 1 centimeter. Then the 10 Newton will be 10 centimeter, which is acting along x-axis. 6 Newton will be 6 centimeter, which is acting on y-axis, and 4 Newton along negative x-axis, which is acting on 4 centimeter. Then I solve this. This is the same numerical 4.1. I take a 10 centimeter with the help of the ruler and draw the line AB. The arrow is pointing in this direction. Then, because he has said to us, that 10 Newton force is acting along x-axis. So that's why I make with the help of ruler 10 centimeter AB as 10 centimeter. Then he said to me that 6 Newton is along y-axis, so I go for 6 centimeter, 6 centimeter, and draw the line B to C. This is 6 centimeter. Then he said to me, 4 Newton along negative x-axis. You know the negative x-axis is in this direction, so DC is 4 centimeter. So then I draw the line A to B, which is the resultant force. On measuring it, on measuring it, the resultant with the help of the ruler, with the help of the ruler. Okay, thank you very much, guys. I hope you understand. And in the next lecture, we will start the problem again, 4.1 to on. So in this lecture, we only solve two examples. Thank you. If you have any